So we've got this rigged up to measure the melting point of our supposed bromination product. At least we hope it's the bromination product. What I've done is I've taken that solid, the 65B in my notebook, and taken some of that 65B and put it out on a watch glass and kind of pulverized it into a powder with a microspatula. So I could get about 3 millimeters of that powder into the melting point capillary. You're seeing that on the right in the melting point apparatus, and you're seeing the thermometer right now. You'll see that the mercury is just above 120. So we're going to turn the dial on the electrothermal melt temp apparatus up to about 5 on the power, about halfway, and we will watch that mercury rise, and we should be able to get any melting point that's between 140 and 200 pretty accurately because of the way the camera's pointing. If it's outside that range, it might be a little off because the camera's not pointing exactly flush. But hopefully this will melt somewhere between that range, because we know from looking up the literature approximately where it should melt. So as long as it melts at least close to where it should melt, we should be right in the range that we need to be on our 400 degree thermometer that we're looking at. So it should start rising fairly soon, and you should be able to watch it and find out when that solid just starts to melt to give the first droplet of liquid, and then when that solid finishes melting so there's no more solid left, and that's the range you're going to want to record. As I think I've said before, the optimum conditions for melting point is that you have your temperature rising at approximately 2 degrees per minute at the melting point of the substance, which will give you a good melting point range. So it's not rising too fast so that it makes your melting point look expanded, but it's not rising so slowly that the compound has a chance to melt before it's really reached its melting point. So each line on that thermometer is 2 degrees. So we'd like it to take about a minute at the melting point to go from one line to the next. So right now it's rising a little faster than optimum, but of course we haven't reached the melting point. But I'm going to back it off a little bit, take it down to 4.6 on the dial, just to get that to rise a little bit more slowly. Should give us a better reading. See that the frame refresh rate on the camera is causing that mercury to look like it's rising in spurts rather than continuously, but I assure you it is actually rising continuously. That's an artifact of the camera. like it has pretty clearly melted.